So today we are solving 6 questions for JEE Mains, and if you get any 5 of them right, 6 maths questions. So if you get any 5 of them right, then you are of course well prepared. That's my assertion. So the first question is a complex number question, and complex number problems you should definitely attempt because those are actually very simple, and this happens to be one of those simple complex number problems. So all we have to do here is that we have to assume that z is equal to x plus iy. Okay, this is very simple standard equation, which of course means that the conjugate of z is equal to x minus iy. Okay, now this equation, all it is saying is that what it is saying? It is saying that my x minus iy is equal to iota into the square of z. So square of z we can simply find out, that is a simple a plus b the whole square formula will apply. So this becomes x square minus y square plus 2 iota x y. Okay. Now from here all we need to do is that we need to separate the real and the imaginary portions, and we'll get two equations in two variables. Very simple. Okay, we are just going directly, very direct. So here the real part is x, okay, and from here the real part I'll get is I multiplied by I will give me -1, so that will become the real part. So this becomes minus 2xy. Now let's just look at this equation a little bit more. Okay, so this is the real part. So from the real part we are getting this. Okay, and let's also just write the imaginary portion here. From the imaginary portion, what do we get? So from the imaginary portion we get minus y is equal to x square minus y square. Now just let's look at this real equation, the equation we got from the real part a little bit more. So what we can say is that x plus 2xy is equal to 0. Now this equation has two solutions. One is if x is equal to 0, okay, so we can take x common and this will become 1 plus 2y is equal to 0. So this equation is satisfied if either x is equal to 0. So we will have two solutions. Either x is equal to 0 or y is equal to -half. Okay, very simple. I have not done anything complicated yet. So now we take the value of x equal to 0 and we go with it for a little while. So in this imaginary equation, this is what I substitute. I substitute x as 0. So what do I get? I get minus y is equal to minus y square. So this becomes y into y minus 1 is equal to 0. And of course this again yields me two solutions. One is that y is equal to 0 and the second one is y is equal to 1. So there are two solutions. So now with x equal to 0 I have two solutions of y. So those are the 2 points. With x equal to 0, y is equal to 0, x equal to 0, y equal to 1. So those are the 2 points I get from here, and the same thing will happen here. I'll get 2 points from here also. So again I substitute in the imaginary portion. So this becomes -half is equal to x square, and this becomes -1/4. So what do we get? X square is equal to this will become, this is +half, sorry, okay, because this is y is -half, so minus become plus. This goes to the other side, this becomes 3/4, or this becomes √3/2. Okay, of course there is a plus minus here. So those are the two solutions. Now I have 4 points, total of 4 points. Now let's just try to plot the 4 points. Of course before we plot them, we only are interested in the non-real roots. Non-real roots are those roots which are imaginary. Imaginary roots I can only get if y is not equal to 0. So this solution is actually rejected. We don't even worry about this, x equal to 0, y equal to 0, because in that case I have a real root. I'm not interested in real root means z would be equal to 0, which is a real number. I'm not interested in those. I'm interested in only those roots where I have the y as non-zero. So let's just try to plot it in the xy plane, or in the Argand diagram, in the complex plane if you will, and this is the real. Okay, so the very first point is 0 and 1. So x is 0, y is 1. So this is right here. This is 0, 1. And what about the second point? The second point, in the second point, y is minus half. So y is minus half right here. So this is minus half. Okay, and the value of x is root 3 by 2 plus and minus. So 1 on this side and 1 on this side. And this is of course root 3 by 2 minus root 3 by 2 comma minus half. And on this side I will have plus root 3 by 2 comma minus half. Okay, so these are the 3 points. I have just plotted them very nicely. Okay, and this forms a triangle. Okay, this forms a triangle. So now all we have to do is that we have to find the area of this triangle, which of course we will find it shortly. But at this point it is very important that you plot these points, form this triangle and get the area. Okay, do not use the shoelace method. Okay, if you use the shoelace method you will end up with a matrix whose determinant you will have to find. That is more complicated. I don't know why students do that, but this is a very simple problem. So this is half into base runs from root 3 by 2 to root 3 by 2 on this side. So this becomes 2 into root 3 by 2, that is my base, into height. Height is of course from, this is 1 and this is half, so height is 3 by 2. Now if you simplify this 2 and 2 would cancel, this becomes 3 root 3 by 4. Okay, and that is our area. Okay, so very simply we were able to solve it without using anything complicated. Okay, just by separating the real and imaginary part. So like I said, complex number questions are simple. You should attempt those. There are very little tricks actually involved. Now this is the question on Rolle's theorem. Okay, so if you know Rolle's theorem, then this is a very simple question. This is not complicated. Okay, and again all we are saying is that we need to find the number of distinct roots. We are not even required to find the roots. We are just asking, it's asking how many roots would be there. So the number of roots is of course those points where this function crosses the value of 0, where y is equal to 0. That is my roots of this function. Let's say this is fx, or this function I call it y. So if y is equal to x is to power 4 minus 4x plus 1, then the roots are when y is equal to 0. Now I have to find how many roots are there. So just by applying the Rolle's theorem, what we'll see is that depending upon how many minima or maxima are there, how many points are there at which its derivative becomes 0, I can quickly then say that how many points would be there where this function would cross the line of y equal to 0, would become 0. Okay, so let's just try to find out. So y dash is equal to 4x cube minus 4, and this is equal to 0. So what about x? So x becomes x cube minus 1. Okay, I'm not making it equal to 0. Okay, so this is y dash. Now I need to find out at what points, how many points are there at which this derivative is 0, at which the slope of this curve is equal to 0. So there is only one real value of x for which that happens, and that happens at x is equal to 1. Okay, so x equal to 1 is one of the solutions. So that is one of the solutions, and at that x equal to 1, what is the value of y? So at x equal to 1, y's value is equal to minus 2. Okay, but this y value is not so important. All we are saying is that x equal to 1, I have this curve will attain a slope of 0. Now with a little bit x, when the x is less than 1, when the x is less than 1, this term would be smaller than 1, smaller than 4, and this term would be more dominant, and so the slope would become negative all through. Okay, when x is greater than 1, the 4x cube term becomes more dominant, and all through, as long as x becomes greater than 1, this particular term, the positive term, will become more dominant, and hence the slope would remain positive. So what kind of curve am I looking at? I am looking at a curve which goes like this. Okay, and this is how the slope of the curve looks like. It goes from all the way from negative to 0 to positive slope. Okay, and the turning point of the slope is actually x is equal to 1. That is the turning point of the slope, and the slope changes from negative to positive. And the other thing about this curve is that, of course, because this is a polynomial, we know that it is continuous and differentiable all through, and that is why we can apply the Euler's theorem here. Now, given this curve, we can easily see that the points at which I have the roots, at which the y becomes equal to 0, the values of x's for which the y becomes 0 would be around this value of x, and there will be two of these, okay, because the curve would start decreasing, then reach the x equal to 1 point, and then it will start increasing. So there will be 2 points at which the curve would intersect my y is equal to 0 line, which essentially means it will intersect the x-axis, and those are the roots. And how many distinct roots will I be? There will be two such points, so there will be 2 such roots. Okay, so just by looking at this, just by analyzing this curve a little bit around the point of 0 slope, we are quickly able to understand how many real roots are there. Now, sometimes it might so happen that my curve does not follow these guidelines. When I differentiate it, my slope I do not get, right. So this equation might not yield a real solution for x, and in that case, what would happen? I have only one real root, or I might not have any real root. I'll have to find out by looking at the original equation, plotting the curve in rough a little bit. In that case, I might not have a real root, or I might have only a single real root. Okay, so those cases have to be analyzed, and of course, we have done those on Doorsteptutor. There are several problems there which you can solve. Really short on time, so we'll try to solve it using a little different technique. So for that, what we do is that we differentiate both the sides with respect to x. So if I do the differentiation, what I'll get is, on this side I have simply an integral, so that integral will be gone because of the differentiation. So I will get e raised to power x divided by x plus 1 the whole square. On the other side, this is the multiplication of two functions. So this becomes f dash x e raised to power x, plus the differentiation of e raised to power x remains as such. So I will get fx e raised to power x. Okay. Now, if we want to, what does this mean? This means that if I cancel out e raised to power x, what I get is, I can say, is f dash x plus fx. What is that? That is equal to x square plus 1 divided by x plus 1 the whole square. So I have to find a function fx whose differentiation, when I add to the original function, I get this expression x square plus 1 divided by x plus 1 the whole square. Now, of course, fx will be a polynomial of this nature. It will be of the form fx will be of the form gx by hx. If I differentiate this gx by hx, I know that in the denominator I will get hx square. Therefore, this hx square will be equal to x plus 1 the whole square. Okay, which means that hx is x plus 1. So now from this I can say that fx is really of the form ax plus b divided by x plus 1. That is the form of fx. I can say that. Now let's just try to differentiate it and see what do I get for f dash x. So f dash x, as we said, the denominator will become squared. So this will become x plus 1 the whole square. That is to be expected. And the numerator will go like this. So first we will write x plus 1. This is the hx multiplied by differentiation of ax plus b, which is simply a, minus, I'll write ax plus b, the numerator, and then the differentiation of x plus 1, which is simply 1. Okay, I'm not doing anything complicated. These are the simple formula. This is the formula for the quotient, if you will. Now this, if we try to simplify it, this becomes plus ax minus ax would cancel. So here I'll get a, and from here I'll get minus b divided by x plus 1 the whole square. So I know what is f dash x, I know what is fx, I plug it into this equation. What do I get? So from, this is equation number 1. So from 1 we can say that f dash x is a minus b divided by x plus 1 the whole square, that is here f dash x. Fx is ax plus v divided by x plus 1. This is nothing but this is equal to x square plus 1 divided by x plus 1 the whole square. Now from here what we'll do is that we'll multiply both the top and bottom by x plus 1. That is what we are doing. So this becomes x plus 1 the whole square, and here I will have x plus 1. Now let's just look at the numerator, because at the denominator we have x plus 1 square, x plus 1 square, x plus 1 square on both sides. So that is in some ways that will cancel out. At the numerator is what we are interested in. So what we'll do is that we will say a minus b plus ax squared plus bx plus ax plus b is equal to x squared plus 1. Now from here we can say that this minus b and this plus b would get cancelled. What we will have is ax square plus b plus a into x plus a is equal to x squared plus 1. Of course, from here it is pretty clear that a has to be equal to 1, okay, because the coefficient of x squared is also 1. So a is definitely 100%, I can say that a is equal to 1. Now what about b? See, the term of x has to be equal to 0. So if a is 1, b has to be equal to minus 1. Which of course means that my polynomial fx becomes, so my polynomial fx, now I can write it as x minus 1 divided by x plus 1. Okay, that it becomes very clear because a is 1, b is minus 1. So fx, my polynomial fx becomes x minus 1, x plus 1. Also f dash x, right? So that is what we are interested in. So from here we really want to start with the first derivative, second derivative, third derivative. Okay, that is what we are interested in. So from here what we will write, f dash x is equal to a minus b, which is 1 minus minus 1, which is 2, upon x plus 1 the whole squared. Okay, now f double dash x, if I take the second derivative, this will be 2 into 2, 4 divided by x plus 1 the whole cube. Now if I want to take triple derivative, what does that become? F triple dash x will be equal to 4 into 3, which is 12, upon x plus 1 the whole raised to power 4. But of course we want to find the value of this at x equal to 1. So we will, that's what we will put. So this becomes 12 divided by x equal to 1. So this becomes 2 into 2 into 2 into 2. 4 times this gets cancelled. So this becomes 3 by 4. That is our answer. Okay. Very, very simple, not difficult question if you approach it systematically. Okay, no tricks involved, no number fudging, nothing is required. Very simply from the basic principle. Now here we have a definite integral, and the problem with this integral, or some might think the problem with this integral is the absolute value sign inside the integral. So this absolute value sign, we don't really know how to integrate. So the entire focus of this question is actually how can we remove this absolute value sign. Of course, on Doorsteptutor we have seen several techniques of getting rid of this absolute value sign, but here we use the specific technique because we have been given a definite integral. So we'll use a very specific technique, and what this says is that we break the definite integral, the limits, into two regions. One is the positive region and one is the negative region. Okay, inside the positive region I know that my limit goes from 0 to 2. So in that region this x cube plus x will be positive, so I don't really need the absolute value sign. That is the first thing. And in this region I know that this x is positive, so I don't need the absolute value sign there also. So I can simply write it like this. Now what about the negative region? So I have broken down my limits into two regions. Like I said, I still need to keep the absolute value sign because there I know that x can be negative So the things inside the absolute value sign are not really guaranteed to be positive. So I need to keep those signs around. Now, of course, at this point, what I'll do is that I'll use a technique, and I'll try to get, using the technique, I'll try to get rid of this absolute value sign. And the technique is, I'll reverse the, I'll change the sign of my limits. So my limit, instead of going from 0 to -2, they go from 0 to 2. I'm changing the sign. And at the same time, because I'm changing the sign, I also need to do this replacement of x with -x. So the two of them I do together, then this, the second portion after the plus, this portion, this expression now becomes 0 to 2 of course we'll keep the negative sign, minus x cube minus x, because we are replacing x by minus x. So that is what this will become, minus x, and then this is minus x and plus 1. Of course, this x cube, this entire integral is again between 0 to 2. So the x will always be positive. So x cube will always be positive. X will also be positive. So this, to get rid of this absolute value sign, I only consider the magnitude of this quantity within. And the magnitude of this quantity is, of course, we can say it is nothing but x cube plus x. Okay, that is the positive value. And from here also we only consider the magnitude, which from 0 to 2, the magnitude of minus x is simply equal to x. So this becomes e raised to power minus x squared plus 1. Okay, and that is the thing here. Now we are done with our technique. Now we bring both the terms together, this term and this term together. X cube plus x, the numerator is common. The limits of integration are also common. So what I can write from here on is 0 to 2 of x cube plus x, and then what do I get in the square brackets? This is 1 upon e raised to power x squared plus 1 plus 1 upon, from here I will get 1 by e raised to power x squared plus 1. Now this term will simplify a little bit, and of course this simplification will do here. So this e raised to power x square will come here. Okay, so this becomes 1 upon e raised to power x square plus 1 plus 1 by 1 plus e raised to power x squared divided by e raised to power x squared. Now this will go on the top, and we will get 1 plus e raised to power x squared divided by e raised to power x square plus 1. Of course these two are the same, so this can be simplified and this becomes 1. So this entire quantity here, this is just 1. So now I am left with this. This is my definite integral, x cube plus x. Now we will write it as x raised to power 4 by 4 plus x square by 2, and the limits are from 0 to 2. The 0 limit, I don't really have to worry about it so much. This becomes 2 raised to power 4 is 16 by 4, and plus x square is 2 square, which is 4 by 2, and this becomes 4 plus 2, which is equal to 6. The negative limit will be minus 0, okay, because as soon as I substitute 0, x raised to power 4 will become 0, x square will become 0, so that limit is just simply 0. So negative limit, the lower limit of the integration, or the negative after the negative sign, I will have just 0, and I only have to worry about the limit, finding the limit of integration, which is the positive limit, or the limit 2, that I have to really worry about. So that is 4 plus 2, which is final answer is 6. So hopefully this question is clear. Now let's move on to the next question. Now here what we have an ellipse. Ellipse is given, and the equation of the ellipse is given in the standard form. That is not very difficult. We have been told that it has an eccentricity. So the eccentricity is given as 1 by 4. So that is the value which has been given. And we also know one of the points through which the ellipse passes. So when ellipse passes through that point, or any, for that matter, any curve passes through a point, we know that at that point its equation is actually satisfied. That is what it means. So with that knowledge, what we can do is that the first thing we do is that we create an equation based on the eccentricity. So the eccentricity we know. So this kind of formula, this basic formula, we really need to remember. So that is the formula for eccentricity. So this we know is 1 by 16 is 1 minus b square by a square, and from here we can find out b square by a square is equal to 15 by 16. That is simple. Okay, nothing difficult there. Now what about this one? Let's just try to substitute this point in this equation for ellipse. What do I get? I get here 4 4s are 16 into, this is root 2 by 5, so this is nothing but 2 by 5 divided by a squared plus y square by b square. Y is 3, 3 3 is 9 by b squared is equal to 1. Now what about this? Let's just look at this equation again. What do we get? I take a square on this side, I take b square on this side. What do I get? I get 16 divided by a square is equal to 15 divided by b square. Now 16 divided by a square appears here, 16 divided by a square is appearing here. So I can simply write 15 into 2 by 5 divided by b squared. Okay, I just simply substituted 16 by a square with 15 by b square plus 9 by b square is equal to 1. So this is 15, 3, 15, this is 3 and 2, this is 6. 6 plus 9 is 15. So 15 by b squared is equal to 1, or we know that b squared comes out to be equal to 15. Now we know b squared is 15. Let's just substitute here. From this equation, if I substitute b squared, what do I get? I get a squared is equal to 16. We have been asked to find a square plus b square, which is 16 plus 15. So we simply do that. 16 plus 15, which is b squared. Okay, so this becomes 651 and this is 31, which is our answer. Okay, very, very simple, nothing complicated. Now with this we come to our last question, which is the question of permutation combination. Again, very, very important kind of problems, very, very scoring. Typically questions are very, very simple. You don't have to do any complicated maths, just you have to only deal with numbers here. So again, very, very simple and basic questions. See, what we have been said is that there are 5 numbers. We have to choose 5 numbers from this set of numbers from 1 to 18, and we are arranging them always in the increasing order. So once I have chosen the numbers, right? So typically when we have numbers, we can typically permute them. So this is a question of, typically it's a question of permutation. But in this case, what has happened is that we are choosing the numbers. Let's say that from this set, I have picked these numbers 1 to x1 to x5. These have been chosen, and what is the number of ways in which this can be chosen? They can be chosen in total of 18C. I have to choose 5 ways in which they can be chosen. So that is simple. That is something that we already know. But of course, when I arrange them in the increasing order, then there is only one possible arrangement that I am dealing with. I am dealing with not all the possible arrangements of numbers x1 to x5. I am dealing with only one possible arrangement that I can have. So the only thing I have to do, it is not a question of permutation. The only thing I have to do is I have to choose the numbers. I cannot permute them. I don't really have the choice. So that is my total number of the ways in which I can, this is my total, basically the universe. This is all the arrangements I can have. This is all the various ways in which I can choose the numbers. This is my universe, because I have to calculate the probability. So this is my total set. This is my universal set. And what is that? It is 18C5. The number of ways I have chosen the 5 numbers from a set of 18 numbers, and then there is no more permutation available to me, because the numbers have to be arranged in only one and definite order, which is only in the increasing order can they be arranged. So this is my total set 18C5, and let us now try to find out in how many ways I can have from this set 18C5, where I have arranged the numbers already in the increasing order. So numbers are already in the increasing order, and now I have to, so this is x2, they are arranged in increasing order. So now I have been said that x2 is 7, so this is 7, and x4 is 11. I have to find out how many, what is the probability of this happening. See, the numbers have already been arranged in the increasing order. From that, I have to find out in which possible, what is the probability of 7 being here and 11 being here. So my universal set is this. Now I have to find out what is the total number of ways in which I can have 7 at x2 and 11 in x4. So this x1 can have one of the 6 values only, because it can go from 1 to 6. It has to be less than 7. Now the x3 can only have values between 7 and 11. So this is what, 8, 9 and 10. So it can have only 3 possible values. And what about this one, x5? x5 can be anything from 12 to 18. Okay, it cannot be anything else. So between this 12 to 18, how many possible combinations I have? I have 7 possible, how many possible choices I have? 7 numbers can be there. So inclusive of 12 and 18. 12 and it can also be 12 and 18. So that's why there are 7. Okay, don't subtract 18 minus 12. Don't do that. Okay, otherwise you will have 6. See, that is an inclusive thing. Number can also be 12 or it can also be 18. So that's why this 7 comes. This is my desired combination. This is my event probability. This event happening where x2 is 7 and x4 is 11, and my universe is 18C5. Now of course 18C5 we can simply simplify. 18 into 17 into 16 into 15 into 14. Of course in the numerator we will have 1 into 2 into 3 into 4 into 5. This 5 3s are 15, 15 is gone, 7 2s are 14, and then we have 6 3s are 18. So this 6, 3 and this 18, this is cancelled. So 2 is left. So this 2 is also cancelled. Okay. Now this 4 is there. So this 4 gets cancelled with this 4. So this becomes 1 by 17 into 4, which is 1 by 68. And that is our final answer. Okay, so again, very simple question. Like I said, permutation combination questions are very simple. It's just that you have to be able to read the English and then translate it into a mathematical form. So typically students get confused there. Okay, so with this, if you are able to get 5 questions right, then you are on right track. If not, some of the techniques that we have here have been discussed in our lectures on Doorsteptutor. So definitely visit there and look at the lectures and solve the practice problems. Okay, so continue solving practice problems between now and advanced or for your BITSAT. Okay, that is very important that you keep doing that. And again, lots and lots of solved problems are available on Doorsteptutor. So don't miss those. Thank you very much.